Today we're going to add vectors. So we're going to start with adding vectors graphically. On a graph, all we need to do to add vectors is move the vectors tip to tail. So you'll see the vectors here. All we do is move these vectors. You'll see the red vector, we keep it still. Then we take the green vector and we move it to the end of that red vector. So you'll see we moved the green vector from here to the end of the red vector. And then we do the same thing with the blue vector. We move to the end of the green vector. And that's how we add them. We add them by putting them tip to tail in a sequence. And in the end, we get a sum, and we call the sum vector the vector that comes from the start to finish. And so this new vector is the one that starts at the beginning and goes to the finish line of all the vectors. And we call this the resultant vector, as it is the result of the addition of the vectors. And if you can download this PowerPoint, I would encourage you to play around with these vectors here and here and try to add them different ways. Try to put them in a different order, because you'll realize it doesn't matter the order in which you add vectors. You will always get to the same result. In this case, we will always get a vector going from start to finish here. So for example, if I did the blue vector first, I can draw a blue vector that goes, I'll try to approximate it as best as possible. About a blue vector that goes about right there. And then if we drew in the green vector, it goes about right there. And then if we add in the red vector, we would get a vector that goes about right there. And you notice, even though we had a different order of vectors, we got to the same spot. And so it doesn't matter which order you add vectors in, you always get to the same spot. And so I'd encourage play around, just moving the vectors. Don't make them longer or shorter, just move them around, and you'll see you always end up at the same point right there. So if we add vectors here, it doesn't matter which one we start with. So let's say we keep the blue one, and so I'm going to go ahead and add the green one in next. Looks like the green one moves about 1 to the left and then 4 up, and so we could call that -1 I hat plus 4 j hat if we want to, just for practice. And the vector looks about like that if we add it to the tip of the blue one. And then the red one moves 1 down and 4 to the right. And so that would be 4 I hat, since it moves 4 to the right, 4 in the positive x direction. And then -1 j hat, because it moves down 1 in the -1 y direction. And if we add it to the end of the green vector, we will end up going about right there. And our resultant vector ends up being, let me actually use orange. This vector that goes from start to finish. We started here, right? Because we did blue first. And then we added the other vectors. And then we got to the end here. And so our resultant vector is from start to finish. And it looks like our resultant vector starts at 0, goes up 3. And so our resultant vector is 3 j hat. Numerically, adding vectors is even easier. You've been doing this for years. All we have to do to add vectors is add the corresponding components. I like to think of these corresponding components as just variables. All we're doing is adding like terms. And so if we have 4 I hat plus 5 j hat plus -2 I hat plus 7 j hat. So if we add these two vectors here, all we're doing is adding like terms. We got an I hat and an I hat, so we're going to add them together. What's 4 plus -2? Well, we get 2 I hat. What is 5 plus 7? Whoops. 5 plus 7 is 12 j hat. And that's our result. All we're doing is adding the I hats and adding the j hats as if they're like terms. If the I hats and j hats confuse you, you replace I hat for x and replace j hat for y. And then it becomes maybe much more obvious. 4x plus 5y plus negative 2x plus 7y. Okay, well that's 2x plus 12y. And then just replace the I hat back afterwards, 2I hat plus 12j hat. And you get your answer. Subtracting vectors is just the same. We have 4I hat plus 5j hat. And if we subtract them, just like if we subtract a group of terms, we need to subtract them with parentheses, like that. So we're subtracting these two vectors. Again, we add the components separately, but this time we're subtracting them separately. And so we're doing 4I hat minus negative 2I hat. Well, what is minus negative 2? Well, that's just addition. And so it's basically 4I hat plus 2j hat, or plus 2I hat, I mean. 4I hat plus 2I hat. And so we get 6I hat. And we have 5j hat minus 7j hat. And so we get a minus 2j hat here. Or if you want to write 6I hat plus negative 2j hat, that is just as fine. Again, if this is confusing, replace the I hat and j hats with x and y's. It'll become a little bit easier. So let me show you what that looks like. We have 4x plus 5y minus 2x plus 7y. And make sure this is negative. Don't forget your signs. Okay, well, we would just distribute this negative first. Right? Distribute the negative across both items. And then add like terms. 6x minus 2y. And then go ahead and replace the I hats back in their spots. And you got an answer. Multiplying by scalar. So we can multiply vectors. We're not going to multiply two vectors together though, because while you can do that, there's actually two different ways to do it, and they're both kind of complicated. We won't do that in our course. That is a higher level physics course. You actually need to go through some calculus first to really understand that and be able to use stuff in physics with those. So we're not going to do that. But we will multiply by a scalar. Remember, a scalar is just a number. We're not multiplying by things with multiple components, just magnitudes. So for example, we can multiply this vector right here by 3. And we would write that 3 times negative 2I hat plus 7j hat. And again, just like algebra, all we're doing is distributing the 3. We're multiplying each term times 3. So negative 2 times 3 is negative 6. And 3 times 7 is 21. And that's it. We're distributing the 3 to both items. So here's the trouble with adding vectors. In physics, most of the time when I give you a vector, I'm going to give you it in resultant form. When we get to forces, I'm not going to tell you you have a force with 2 components. I'm going to tell you have a force of 5 newtons and it's acting at 30 degrees. I'm going to give you in resultant form. And you have to add the vectors, but it's really hard to add vectors in resultant form because they're at different angles, and if you graph them, you're just approximating, and so you need to convert to component form. We have to convert our vectors first to component form, because then it's really easy to add them. We just add the components. And then we had to convert them back, because most often I want my answers in resultant form as well. So here's the step-by-step guide of what to do. The first thing you're going to do is get all your vectors in component form. They may already be given to you like that, but probably not. Probably they're given in resultant form. And remember, we convert vectors to component form with these 2 equations. It's really easy. You need the magnitude r, which is almost always given, and you need the angle But remember, this angle is the one with respect to the horizontal. Remember that we practiced getting the correct angle depending on what angles they give us. We also need to add, subtract the vectors. Step 2. So what we just learned how to do, we need to add and subtract them. And then the third thing we need to do is before we convert back to resultant form, while we have the component form, because we just added them, and so we got a vector maybe like 3i hat plus 4j hat. While we still have this, let me go ahead and hit -3. I'll change up that vector. Let's say we got -3i hat plus 4j hat. While we have it in component form still, go ahead and sketch the resultant vector. And when I say sketch, I mean quick 2-second sketch. Draw your axes and then tell me which quadrant it's in. In this case, it's going to the left because it's negative there, and it's going up because it's positive there, and so it's going in this quadrant. It's going left and up. It's in quadrant 2. Then you can go ahead and convert back to resultant form once you have your sketch. Go ahead and use this equation, get your r, and then use this equation to get your theta. And this is the reason we sketched it, because remember, we need to determine the quadrant. Let me go ahead and erase that. Remember, we need to, once we have the angle after this, it's not always the correct angle. We might have to add some degrees depending on the quadrant we are in. And so in this case, we are in quadrant 2. And so whatever angle it spits out with this equation, we're going to need to add 180 degrees to it. So let's try it. We're going to add 5 at 30 degrees and add 8 at 110 degrees. So first step, get to component form. 5 at 30. Well, we're going to do 5 cosine 30. And our y component is going to be 5 sine 30. And let me use my calculator. 5 cosine 30 gives me 4.33. And 5 sine 30 is going to be 2.5. And so we can write our new vector as 4.33 I hat plus 2.5 j hat. Our other vector is 8 at 110. And so our x component is 8 cosine 110. Our y is 8 sine 110. 8 cosine 110 is negative 2.7. We'll round here. 8 sine 10. How do you know where to round? Generally, when you're writing stuff down, round where you think is appropriate. Keep at least 2 decimal places probably. However, in your calculations, if I ever use these numbers again, I'm going to go back through my TI-84 and click that number. I'm not going to use a rounded number. I'm going to go back to the exact number and use it again. And so try not to round in your calculations. Try only to round on the page. And at the very end, round where you think is appropriate. We're not using sig figs. Just don't give me 30 decimal places. Give me 2, 3, maybe, depending on the number. If it's a bigger number, like in the 100,000s, you probably don't even need decimals. Round somewhere close to 10,000, 1,000. Round where you think is appropriate. All right, let me change colors. All right, 2. Oh, and let me go ahead and write this. Negative 2.74 I hat plus 7.52 j hat. All right, step 2. Add the components. All right, so we're adding 4.33 I hat plus 2.5 j hat minus 2.74 I hat plus 7.452 j hat. I said that wrong, but I wrote it right. Okay. and this looks messy. I'm going to move it up here. Combine like terms, 4.33 I had, and so I know that I had a longer decimal there, so I'm going back in my calculator and highlighting that 4.33 and hitting enter, so it brings it down, plus, and then I'm going back to that negative 2.7, hitting enter, brings it down, hitting enter. And then it gives me 1.59 I had. Again, I'm rounding on the page, but I'm not rounding in my calculator. I'm using the numbers from before. And then, thankfully, 2.5 was exact, so I'm going to go ahead and type 2.5. And then I'm going to add, and I'm going to go back to that 7.5, highlight it, hit enter, so it brings it down, and hit enter, and get 10.02 J hat. Okay. Whoops. My bad. I need to bring me down the menu. All right. Step 3 is do a little sketch. Boom, boom, positive, positive, boom. All right. And that's it. That's all you need to do for a sketch. 4. And if that was confusing, they're both positive, which means they're both in the first quadrant. If you have, you can think about it like a point. If you have 2 positive points, they're in the quadrant. If your x is negative and your y is positive, then it's in quadrant 2, and so on. Number 4 is convert back to resultant form. So r equals the square root of x squared plus y squared. And in my calculator when I do it, I'm gonna go back to that 1.59, hit enter, square it, plus, go back to that 10, hit enter, square it, and I hit the wrong thing. Let me square it, get an answer, and then with that answer, I'm gonna hit square root, answer, and it gives me 10.014. And that should kind of make sense if you were to give a more accurate sketch. Because we're barely going over in the x, we're moving pretty high up in the y. It looks kind of like that, this vector right here. And because it's such a high slope, this side length is going to be pretty close to the result, to the hypotenuse. And so this number right here should be pretty close to this one. So that makes sense. All right. And then theta is inverse tangent of y over x. And so again, I'm going to hit inverse tangent. I'm going back to that 10.017. Dividing by, going back to that 1.59, hitting enter, closing the parentheses, and enter. And I'm getting 80.95, so 96 when we round it, degrees. And I need to check this answer. Do I need to do anything to it? Well, I'm in the first quadrant, and so no, I don't need to do anything to it. And so my answer is 10.14 at 80.96 degrees. I'll check it with this one. I got the same answer here, except for I think I rounded more here, but about the same answer, and I would take both. And if you have issues with Quest at all with this, let me know. Make sure you're rounding as little as possible in Quest. Quest is a little bit picky. If you have an issue and you see that the answer that you were giving is different than the answer they told you was correct, let me know and I'll go back through and I'll give you credit. I can go back through and give individual answers credit in Quest. And so go ahead and email me if you're having issues and I'll help you out. But most of the time I find that you guys complain about it, but the answer really is different than what you think it is. And so, but if you are having issues, let me know. With that, I have no more notes for you guys for today. That's how you add vectors. Go ahead and do the Quest. And let me know if you have any questions. Come to tutorials, come to class for questions, and have a good one.